project. I did 3 different topics from this year: volume, lines and angles, and diameter and radius. So just want to go over the first one, volume. Alright. Volume is trying to figure out what's inside a cylinder or a triangular prism as shown here. So basically, like if you're going to try to fill it up with fluid or something inside of it. And to find out the volume, what you have to do is, for a cylinder, you do pi radius squared times the height. So what I did here was pi 3.14 times 5 times 14 and got 219.8. I don't know if you can see that. So pi times 5, 3.14 times 5 times 14, which gets 219.8, as you can see. Then over here, for a triangular prism, it's the Pythagorean theorem, so it's a squared plus b squared equals c squared. And you do a squared plus 10 squared equals 15 squared, because I'm just literally plugging in 10 and 15, and then 10 squared is 100, 15 squared is 225. So then you know that you have to take your answer, 225, and subtract it by 100, which is 10 squared, or b squared I should say, and then you get 125, and then once you get 125, you do the square root of 125, which equals 11.180, approximately 11.2. And then once you have that, you can find the volume. And for the volume, you do base times height and half. Well, you need the half times base times height, so 0.5 times 10 times 15, which gets you the first part of it. And then once you get the half, 0.5 times 10 times 15, you multiply it by 11, and then the total volume is 825 cubic centimeters. And the reason why I chose volume was because it was kind of a hard topic for me to understand, like especially the triangles and stuff, other shapes. I struggled with it, but now it comes pretty easy to me, so that's why I chose it. And like a real life example would be if I'm trying to figure out, say I'm inventing like a new can of some sort and I want to figure out how many ounces I can put in it, or some type of measurement. This would be a great way to find out, depending on the base and the height and all that. Alright, the next topic I have is lines and angles. So we'll start off here. Alright, here we go. Right here is line M, which has point P on it, and line M contains P, point P right there as you can see. Then line M passes through point P, so passes through point P. It's like if you had to stop, point P would be in the way. Alright, move over to this intersection right here. Lines L and M intersect in T, so lines L and M intersect at T, the middle spot right there. Point T is the intersection of L and M. Point T is also on L and M, so L and M, T's right in the middle. There's no way he's sneaking out of there. Okay, move over here to this one right here. We got C, B, and A, well, A, B, and C I should say, and you're trying to find AC, so you have these two right here, the length of each one, so 3.3 and 3.3, so together these are 6.6. And to find AC, you have to find out the line AC, so not point AC, you need to find line AC. And then point B is between A and C, so AC is found by adding AB and BC, so you add AB and BC, so basically trying to find from point A to point C. And what you do is you add the 3.3 from A and the 3.3 from B to get C. So 6.6 would equal AC from here to here, and it's 6.6 centimeters long. Alright, now we'll move down to the angles right here. Alright, so right here is a right angle. Right angles are 90 degrees, and right angles are found in squares. There's 4 of them in a square, which equals 360. And right here we have an acute angle, which is angles that would say 45 and 45. They make up to be a right angle. You find a lot of acute angles in equilateral triangles. Lots of triangles. There's always pretty much an acute angle. And well, there always is an acute angle, I should say. And so an acute angle is below 90 degrees, has to be smaller than it. And there's 360-degree acute angles in an equilateral triangle. And right here we have our obtuse triangle, which is bigger than 90 degrees. So it's bigger than 90, but it cannot be bigger than 180. So it could go up to 179. And an obtuse angle would be like your laptop if you had it open. Might be at a obtuse angle. It's a real life example there. Real life example of an acute angle would be a slice of pizza. That would be an acute angle. Got your slice. Alright. For a right angle, they're everywhere. Literally signs, textbooks, this piece of paper right here, my MacBook, just hundreds of examples. Alright, right here, P and M. This is a real life example of this line right here. Could be say a road with something on it like a sewer cap. So M would be the road or the line, and then P would be the sewer cap on the road. And they're trying to figure out where it is in comparison to the road or line M. Then we got a intersection here. This would have to do with roads. So say you're trying to cross, and you got your 2 lanes here, your 2 lanes here, you got 2 lanes here and 2 lanes here, and you're trying to figure out how to go from here to here. That'd be an intersection. Like if I'm trying to go this way and you're trying to go that way, we're going to intersect. So that would be that. And then right here, these 3 points on this line, A, B, and C, would be like houses. So 3 houses in a row. Say your friend lives at C and you live at A. You know how far it is to your neighbor's house, B, but you're trying to figure out how far it is from your house to your friend's, which is C, which you could figure out by adding your part of your house to the neighbor's. So like say your house is 3.3 as here, and the neighbor's is 3.3, add that to get the total distance C. Alright. I also chose these because this is probably most enjoyable activities I did this year in class. I really liked working with angles and lines, and it was a lot of fun. You could always relate it to something in real life, which was easy to picture in my head. It was diameter and radius. So like trying to figure out what the whole length of something would be. Like a perfect example would be like pizza and stuff. It's probably everyone would know. So if you're trying to find the diameter, you do 2 times the radius. So the radius is half of the circle. So from like J to R, or K to R, I mean something like that. And then what you do if K to R equal 10, if you're trying to find KH, which is just all the way across, which would be the diameter, you would just multiply by 2, the radius times 2, and you get 20, which is your diameter. Then to find the radius, going the opposite way, if you know the diameter, basically it's half of it, so you're going to divide it by 2. So say right here, A to Z, right here, A to Z is 20. Then if you're trying to find this right here, the radius, then you would have to divide this by 2 here to get your radius, and you get 10. And the reason why I chose this is because it was pretty hard once you get like really sophisticated in it, and like there's always a lot of points and stuff, and you have to really be careful on like which ones you choose as your diameter or radius, because like might not always be right. And we did a lot of pie charts in like schooling and stuff, and this reminded me of it, so like it was pretty cool. And that's pretty much it. Diameter is just like finding the total from top to bottom of the circle, and radius just like half of it. And that's my project for the math project.